This wheel is suspended in such a way that there is no gravitational torque on it, like there was here. But I can put a torque on it by simply putting some weights on the axis. And what do you think will happen now if I put some weight here on the axis? So the wheel is spinning, but now I'm going to put a torque on it here. It is spinning in this direction. Angular momentum is pointing straight at me, away from you. I'm going to put a torque on like this, putting a weight there. Torque will be in this direction. What will the spin angular momentum do? Torque is in this direction, spin angular momentum is in this direction. Spin angular momentum will start to chase the torque. Watch it. There it goes. The spin angular momentum is chasing the torque. You see exactly this.
The gyroscope will remain pointing in precisely the same direction it was when it was spun up.
Okay, this is the direction of my spin angular momentum. And I'm the airplane. And I'm going to fly. Look at that spin angular momentum. It has no respect for me. It stays in the same direction, no matter how I fly. And the error signals that come from the bearings of the yellow housing and the black housing, those arrow signals are fed back to the automatic pilot, and so the plane will stay on course. Now what I can do for you to come to a final test on your thinking, this wheel, you see exactly the same thing that I've shown you before. And if I make the torque higher, then the precession frequency will go up. See, it stops now immediately when I take it off. Put it back on again. Continues. Put more on it. Goes way faster. What happens now if I put the weight on this side? So I change the direction of the torque. If I put it on this side, torque is now in this direction. Spin angular momentum is in this direction. It's going to reverse direction. There we go. And you see it does. Amazingly non-intuitive. If you have problems with this, you're not alone. See you Wednesday.
So there we had a demonstration of real physics with practical applications in the real world, which can only work above a flat, stationary Earth. They just would not work if the Earth was a spinning ball. Gyroscopes wouldn't be used because of the properties that they have. And as he said, it was amazingly non-intuitive when he added the weight or mass, because we would expect the increase of mass on one side to make the gimbal of the gyroscope point down towards the Earth. But because it was spinning, and because gyroscopes always maintain the axis at which they were spun up at, the gimbal did not tilt, and so it becomes non-intuitive. And therefore, aircraft simply are not following any alleged curvature of the globe Earth when they are using gyroscopes to maintain level flight. Thank you very much.